Alright, whatever time you're watching this educational video, this time we will be talking about motion. motion. I guess this is one of the best concepts that you should be familiarized. I guess motion is one of the concepts that relates to physics, and we should really know the meaning behind motion, because everything that moves, physics will be there to explain that. Okay, so let's have what is motion. It's a cliche answer. Motion talks about movements. And when something is moving, there's a change in position, okay, from one point to another point. Let's say a ball is falling down. So this is going to be the initial position and it's going to be the final position. So there is a change in position when there will be movement. Of course, with respect to these two important things, we have the time and a reference point. Okay, we will be talking more about reference point later on. And always remember, motion is not absolute, but it always relative. So relative means we don't have the same perceptions towards motion unless we use this reference point to describe the motion. And our North Star, our guiding principle for this first slide of my presentation: object is in motion if it moves from one place to another. So that's going to be the change in position as time passes with respect to a reference point. So we will be knowing what is reference point later on, and the types of motion will be separated. I will be making another video for that. But yeah, subscribe. Example, we have a car traveling on the road, and we have a falling ball, and we have a person standing still relative to the ground. So the ground is our reference point. Okay, please take note. And then we will try to identify if there is motion in these three scenarios here. Very easy activity. Okay, a car traveling on a road. This is going to be our reference point here. Road, and the car is moving, of course. This is in motion. Easy. A falling ball, yeah, due to gravity, it's still in motion. Then a person standing relative to the ground, standing still. So this is going to be not in motion. It's at rest. And we have another North Star in this slide. Motion always depends on what you compared it to. So that comparison, either a thing or whatever, we call it here as a reference point. It's the basis for determining motion. Without reference point, you cannot describe perfectly the motion of the object. Example, here we have an example. You are sitting in a moving bus. So this is going to be our reference point here, a moving bus. But what if you are relative to the bus? Okay, you're focusing on the bus, you're there, you're just sitting on a bus. So what will be the state of motion? What will be your state of motion? You're just sitting on a bus. The bus is your reference point. You're just sitting there. So you are not moving. You're just sitting there. Although the bus is moving, but the reference point is the bus itself. And you're just there sitting. So not moving relative to the bus. But if you are sitting in a moving bus relative to the ground now will be the reference point. Okay, so on the ground, when you're observing on the ground in a moving bus, you're sitting there and the bus is moving relative to the ground, so you are definitely moving. I hope it makes sense. Relative to the bus, you are sitting. Relative to the bus, you're not moving. You're just sitting there. Relative to the bus, that's the reference point. Relative to the ground, in a moving bus, you're sitting there in a moving bus, and then relative to the ground, your reference point is the ground itself. So you are moving along with a moving bus. So you are moving. Let's talk about components of motion. Of course, change in position, the time, and this reference point that I discussed a while ago. Reference point, it's the basis of comparison. Again, you have to select the reference point and then you can describe the motion of a certain object or mechanical object. Okay, basis of comparison, it's a fixed place or object. It could be a fixed place or an object that you use to compare position and decide whether something is moving or not moving. Just like the example a while ago. Relative to the bus, you're just sitting relative to the bus, so you're not moving. As bus is your reference point. But a moving bus, you're sitting there, and then the reference point is the ground where the bus is moving, so you're also moving. Okay? So reference point is very important in determining the motion of the object. And common reference points, we will discuss the common reference points used in physics problem. You have the ground, or let's say Earth. You're on Earth. The ground, that's the reference point. A moving vehicle like bus or tricycle or motorcycle. Much advanced, we have the center of mass of a system. It could be used as a reference point, especially if we will be dealing with rotational motion. But we will be discussing that one soon, okay? And then, or could be another object. So these are the common reference points used in physics problems. What will happen if there's no reference point? Without without the reference point, motion has no meaning. Motion has no meaning since motion is always relative, right? Always relative and not absolute. So without reference point, motion has no meaning since motion always is always relative and not absolute. Why is it crucial? Why is it important? Okay, because the object is moving relative to something in order for us to perfectly describe the motion. So without the reference point, again and again, the motion will have no meaning. Okay, so there is a certain statement here that you cannot say, it's wrong to say the object is moving, and that's it. So that's not a perfect description of motion. It must be the object is moving relative to something, relative to the ground, relative to the seat of a moving vehicle and stuff like that. Okay? And yeah, I hope you understand something about the components of motion, especially the reference point, the importance of reference points. Now, decide the state of motion. Let's have a statement here. Inside the moving bus, someone is sitting on a seat. So if someone is relative to the seat, that's the reference point. The bus is, although the bus is moving, but yeah, someone is sitting still relative to the seat of that bus. So what's the state of motion there? If this will be the reference point, so not in motion. You're just, someone is just sitting there on a seat. Seat is our reference point. But relative to the ground where the moving bus is moving, you're also inside the bus. You're moving along the bus in one system, so you are in motion. Next, an airplane is taking flight or about to take flight. So a passenger walking inside the plane. Okay, there's a passenger walking inside the plane. That walking passenger relative to the plane, is it moving or not? Of course, it move in motion, but slow manner. The passenger inside the plane walking, so of course, obviously, it's in motion, but it's a bit slower. But what about relative to the ground? Again, the ground is now our reference point, and then the passenger walking inside the plane, and then the ground is our reference point. Yeah, you are, or that passenger, walking passenger is in motion, but this time it's moving fast. In this case, there's addition of velocities of that walking passenger inside the plane, and then the plane itself moving with respect to the ground. So you add the velocities of the walking passenger and the motion of the plane with respect to the ground. So the motion will be faster than the walking passenger inside. Okay, I hope it makes sense. Letter C, standing on earth. You are standing still. So you're not moving, you're just standing there, waiting for something, or probably. Relative to earth, your reference point is on earth. Relative to earth, you're not moving. But relative to the sun, remember, the sun is our reference point, and earth is revolving around the sun and rotating on its axis. So therefore, you're part of the earth system with respect to the sun. So you are in motion, or you are moving. Okay, so to test your way to describe motion with respect to a reference point, I want you to interpret what's inside the table. So we have situations here: book on a table, and then passenger in car. We can describe these situations in terms of their state of motion when we have reference point. So book on the table, it's steady, it's still not moving, but the reference point is on the table. What's the interpretation? You can pause the video and then you can answer it on your own. Okay, what about when the book on the table inside a moving train? What will be the interpretation now? Passenger in a car, the reference point is car, and then another reference point is road. So you have to interpret. Okay, book on the table, tables are reference points, so not moving, so not in motion, or it's resting. For moving train, and then there's a book on the table, and moving train, book on the table on a moving train, it's still not moving. My apology. A moving train, and then a book on a table on a moving train, it's not moving. Unless there's another option here, a reference point will be ground, or yeah, the ground where the train will be moving. So in that case, the book is definitely moving in that case. Passenger in a car. So in a car, the passenger is not moving, but if our reference point will be the ground, so the passenger is moving. You get the idea of how to determine or describe the motion with respect to the reference point. And this is gonna be the last slide. So don't forget to subscribe to this channel to support me in making these contents, and then like and share, especially those who need this. Now, the North Star of our discussion, whatever time you're watching about motion, the reference point is the basis for determining motion. Without it, motion cannot be defined. And remember, a reference point could be object, could be a moving vehicle, center of mass, ground, okay? And nothing is truly moving. Nothing is truly moving or resting unless we choose a reference point to compare it with. With the presence of, or with the identified reference point, we can decide that the object with respect to something is moving or not. Okay, thank you so much for watching this educational video, and I hope you learned something about motion. And yeah, don't forget to subscribe and like to support my channel. Thank you so much and have a great day.